Hello, algebra students. We're looking at section 5.5 today. This section takes sort of a big picture look at polynomials. It gives us some of the terminology and discusses some characteristics of polynomials. So let's look at some of that terminology. We have this sheet which gives these definitions, so you guys can take some notes. First of all, degree of polynomial. What is the degree of a polynomial? It's the greatest degree among the terms. Look at the exponents. So, for example, we have this polynomial, and it has several terms. So, for example, this term right here, that's degree 3. Okay, because the exponent in the term has the power 3. This term, what is its degree? Well, it is degree 1. We don't write the exponent there usually, but there is an exponent of 1. If there's no exponent at all, it's understood to be that. So the one that's underlined here has a degree 5. That term has degree 5 because it has the exponent, and that is the greatest degree among all the terms, right? Is that one. So we say that's the degree of the polynomial itself. If someone asks what degree is this polynomial, we say that's degree 5. Okay, because that's the greatest degree among the terms. Okay, next we have end behavior. This describes the directions of the graph as you move to the left and to the right away from the origin. So, right close to the origin, and as you move away from the origin, it might have some ups and downs in the graph. But as you move away, when you get away from that part around the origin, that's when we're talking about end behavior. Okay, so as you move to the left, does it go up or does it go down? We'll look at this graphing calculator. This is an online graphing calculator, and we have over here a polynomial. And what's the degree of this polynomial? Well, I'm not sure how well you can see it, but the largest exponent is 5, so it's degree 5. And this is it. It has this curly Q. As we start at the origin and go to the left, looks like it goes down, and as we go to the right, it goes up. Now that's the end behavior, but we need to scroll out somewhat to really make sure it doesn't loop back again or something. And we can tell pretty well with this one that as you go to the left, the graph goes down. As you go to the right, it goes up. Okay, that's end behavior. We could change this and look at some other ones. What if we made this a polynomial of degree 4 just by changing that largest exponent from 5 to 4? Okay, then we have this. So what is its end behavior? Looks like as you start at the origin and go to the left. Now here's the origin. When we go to the left, the graph actually goes down a little bit, but the end behavior, as we keep going to the left, it goes up and up and up. And if we start at the origin and go to the right, it also goes up. So that's the end behavior of this one. I think let's go ahead and make it a third degree polynomial just for fun. So we change that to 3. And at a glance, this may look like the end behavior is to go up, but let's scroll out on this. Oh, it looks like it curves back around, and it takes a little bit for it to do that. This is all the way out to -20 before it's back to the 0 point and starts going down below 0. If we look at a big enough picture, we can see that where it goes down again. It's all the way up to 200, and then it comes down. So the end behavior, though, as you start at the origin and go to the left, if you go far enough, it goes down. And if you go to the right, it goes up. Okay, that's the end behavior of that polynomial. Okay, let's go back to our notes. Next we have terminology. Monomial is just a single term, a number, a variable, or numbers and variables multiplied together. We could look at a couple examples. 7. Okay, that's a monomial. It's a number. What if we said x? That's also a monomial. It's a variable. And of course it can be numbers and variables multiplied together, something like 3xy squared, and then we could throw in a z just for fun. 3xy squared z. That is a monomial. Those are all monomials. Polynomial is just the sum of monomials. That's it. You just add them together. For example, 2x squared plus 4x minus 3. That is a polynomial, the sum of monomials. Now we say sum, and you might say, well, it's got a difference in there. But that can be written as a sum also, right? 2x squared plus 4x, and then instead of saying minus 3, we could say plus negative 3. So it's still a sum, it just has a negative number in there. Okay, so the standard form of a polynomial is important. It just arranges the terms by degree in descending numerical order. So, for example, we have here this example right here. Y equals x to the 6th plus x to the 5th minus 2x to the 4th, and so on. They're arranged by degree in descending numerical order. And degree, of course, is the power that the variable is raised to. And those powers get smaller as you go from left to right. Okay? That's standard form. Turning points, a point where the graph changes direction from upwards to downwards or vice versa. And we saw some of those turning points in the graph that we just looked at. So we have a turning point here right around 200, for example. It turns around. And another one at the origin, okay, goes the other way. All right. Okay, so let's look at the next page. I'm trying to get this again. I'm not getting this. Open recent. Here we go. And we want to look at page 2. So here we are. A little tedious to get these brought up to the right size sometimes. Okay. So now that we know about degree and we know about end behavior, we can classify polynomials. And here are the classifications. So this is what all educated algebra students know. So these are things you should memorize. And they're not really too hard. This gives the degree of the polynomial. Remember, and that's just the degree of the term that has the greatest degree. That becomes the degree of the entire polynomial. The name of the degree. So these are some names you should learn. If that degree is 0, that is, you have x to the 0, which is just 1. In other words, you don't have any variables. That polynomial is called a constant. And here's an example, just 5. How many terms does it have? Well, this example has one term. You could have more than one if you had a constant plus another constant, but that wouldn't be simplified, right? Because we can just add those together and get just one number. So the name for the terms is a monomial in this particular example. So the next one we have linear. And now that is when you have a degree 1. So degree 1 is called linear. Here's an example, x plus 4. Number of terms is 2. Name for terms, well, we call that a binomial, this particular one, because it has 2. Now, not all linear polynomials are going to have 2 terms, but this one does, and so that's why we call it a binomial. Okay, if the degree is 2, we call that a quadratic. So this you probably won't have too much trouble remembering because quadratics have x squared in them, right? Which means degree 2. That's power. Degree of 2 means power is 2. That means we're raising something to the second power. That is, we're squaring it. And we call those quadratics. Here's an example. This particular example has one term in it. Other examples will have more. So we call it a monomial since it has only one term. Okay, degree 3 we call a cubic. Here's an example. The largest degree of any of the terms is 3. Okay. And this one is a trinomial. So we're just getting in this name for terms. I want to be clear, these only apply to the specific example that we're given. It does not mean that any cubic is a trinomial, because some cubics have more terms than that. It's just that, okay, here's something with 3 terms. Since it has 3 terms, it's a trinomial. So the next one is degree 4. It's a quartic. And here's an example of a quartic. Has degree 4. The largest degree of any of the terms is 4 because that's the first term. Number of terms in this example is 2, which means it's called a binomial. As that's the terminology you also need to know is if there's one term, it's a monomial. If there's 2 terms, it's a binomial. If there's 3 terms, it's a trinomial. And we'll get to this last one with 4 terms in a second. We have this quartic, if the degree is 4, and then degree 5. That's quintic. Okay? And this particular one has 4 terms. And if they have 4 terms or more, we just call them polynomials. Okay? So you know, this terminology shouldn't be too hard. We've talked about monomials quite a bit already. Maybe you've got that one down. Bi means 2, right? Binomial has 2 terms. And tri means 3, so trinomial has 3 terms. And more terms than that, we just call a polynomial. Okay. Of course, the other terminology this includes is for the degree of the polynomial, you have these terms. Degree 1 is linear, 2 is quadratic, 3 is cubic, 4 is quartic, 5 is quintic. Okay, so we got a couple examples here. Name by degree and number of terms. So this first one, it's a binomial because it has 2 terms, and it's a quintic binomial. Okay, because the degree is 5. Okay, it's a 5-degree polynomial called a quintic, and since it has 2 terms, we call it a quintic binomial. B is a cubic monomial. Just 1 term, so it's a monomial, and that term has x to the power of 3, so it is a cubic because that is one of the terminology things that we learned. We can scroll back up and look. Yep, there it is. a degree of 3 makes it a cubic. Okay, this just says write in standard form and then name by degree and terms. So this is something you might be asked to do on a quiz or a test. Standard form, remember from the first page, means that the terms are in descending order by the degree. So the one with the greatest degree, the term with has the variable to the highest power comes first, and then they are in descending order. So on this first one, write in a standard form. Well, it's rearranged, right? At the beginning, this thing has this 3x first. Well, that's has a degree of just 1. Okay, so that's not the greatest degree. This has a degree of 2. So we put it first, and then the order is right here. 9x squared plus 3x plus 5. That's in standard form because they are in the correct order, with the degree getting smaller as you go from left to right. Okay, and what would that be called? Well, because the largest power is 2, we call it a quadratic. So it's a quadratic trinomial. Okay, so the next one, take a look at that. It has this x to the 4th. Okay, so that one went first. And when you're writing these down, you can cross them off as you go. So there's x to the 4th. And then you see this has 10x squared plus a negative 6x squared. So we have to combine those. And that was 4x squared, which is what we have here. And then 4x. That's right here. That's the next one. And is that it? Well, then we have the constant term. No variable at all. So if it did have a variable, though, it would be x to the 0. Well, x to the 0 is just 1. So that's the smallest degree. It's degree 0, right? And so it goes last. When we write them down in standard form. Okay, so just about done. We look at this end behavior table. So this is talking about, again, if we start at the origin and you go to the left, how does this act? And if you go to the right, how does the function behave? So the rule is, if a, and a is the coefficient of that term with the greatest degree, and that was actually on the other page when it had that. That's okay. I didn't mention that on the other page. I just realized. So a, maybe I should write that in here. A being coefficient of term of highest degree, we'll say. When you see that term that has the highest degree in the polynomial, look at its coefficient. That's a. Okay? So if a is positive, we have this end behavior. For n being even, and n, let's tell what that is. That is just the degree of a term. You know, it's the exponent that the variable is raised to in that term. So in this case, of course, we're talking about the term of highest degree. Let's see, can just say the degree of the term of highest degree. So what is the degree of the polynomial? And you know, for this one, we should just say it that way. I'm going to rewrite that. Degree of the polynomial. Oh, and I erased too much. It's okay, we can put it back. Degree of the polynomial. Okay, so if the coefficient of that term of highest degree is positive, and then if n is even, that is if the degree of the polynomial is even, the behavior is to go up when you go to the left and also up when you go to the right. Okay, that's what up and up means. The first word describes the end behavior as you go to the left from the origin, and then the second one describes end behavior as you go to the right away from the origin. Okay, so we have the whole story here with a being positive or negative and with n being even or odd. And just we'll go through that quickly. We already looked at the first case, a positive and n even. What if a is positive and n is odd? Well, then when you go to the left, it's down, and when you go to the right, it's up. If a is negative, we have that it's down as you go to the left, and also down as you go to the right, for n being even. Okay? And then if a is negative and n is odd, we have this here. As you go to the left, it goes up. As you go to the right, it goes down. So notice that when n is even, okay, it's either, well, when n is even, the graph goes the same direction, either up or down, when you go left or right. And that's like a parabola, for example. It might open up and it might open down, but it has n of is even, right? For a parabola, that's a quadratic. N is 2. So according to this table, it should go the same direction as you go to left and right. That is, they either both go up or they both go down. And we see that that's what a parabola looks like, right? They either both go up if it opens up, or they both go down if it opens down. And we saw that, you probably didn't notice, but when we were playing with this graphing calculator a while ago, we saw that for this one, for example, that we had up there, n is odd. It's 3, right? So when you go to the left, it goes down. When you go to the right, it goes up. That's what we had for odd power, or for an odd degree. And a is positive on this one. Okay. So it occurred to me we might want to actually draw those pictures if we have room on this paper, on this page. Let's squeeze this in. So when n is even and a is positive, you have end behavior that goes like this. Okay? Up when you go to the left and up when you go to the right. Well, what about when a is negative? Okay, well, then it just turns around, which we see this with parabolas, right? Okay. A is positive and N is odd, it goes down and then up. And that's like the one that we just looked at. A was positive in that, and N was odd, right? A is positive, N is odd. Let's look at it. So A is positive, 1/5. N is odd, 3. And when we go to the left, it goes down. When we go to the right, it goes up. Just like the table says, down and up. So we might draw it like this. In between, there might be curly cues. Might go up and down a little bit, but end behavior is what it is, okay? When you go to the left, it goes down. When you go to the right, it goes up. And by the way, I should also mention ones that have even can also have some ups and downs. Our example that I drew in here does not, but you could have something like this, and it kind of does a W-like thing like that, and ends up going up when you go to the left and up when you go to the right, but has ups and downs in between. Okay. So we didn't draw a little picture for A being negative and N being odd. Well, but it's just when you go to the left, it's up, and when you go to the right, it's down. So something like this, okay, would be what you have when A is negative and N is odd. Okay, so have some examples here. Determine end behavior. The first one, and all you look at is the power. Okay, that's N, and it's the power that you have in the term of greatest degree. So we don't even look at that 3. Okay, it's only the largest one that counts. Okay, and it's 4, and which is even, and A is positive. Okay, that's A right there. So you have A positive and N even, which means it's this one, up and up. Okay, and there it is, up and up. This other this other notation just means as you go to the right, it goes up, and then as you go to the left, it also goes up. Okay. Okay, so this next one is A is negative, right? And N is even. Okay, so A negative and N even, that's this one, down and down on our chart. Okay, and and so that's the answer, and this other notation is here as well. As you go to the left, it goes down. That's why we have negative infinity here. And as you go to the right, it also goes down, and the negative infinity means that. Okay, over here we had positive infinity. That's what corresponds with up. Okay, one more. And this time A is negative and N is odd. Negative and odd, that's this case right here. Up and down. So you can just write up and down if asked to describe the end behavior. If they want you to use this infinity notation, you could use it as well. And here we have positive infinity right to the left. As you go to the left is positive infinity, and that corresponds to saying up. And then and down, well, that means when you go to the right, it goes down. So then that's negative infinity means going down. Okay. So that's really these rules. They apply. You know, it's pretty simple because you have just the two cases. The degree of the polynomial that is in could be even or could be odd. Okay, and for A could be positive or negative, and then this table describes, you know, the behavior of all of them, all the polynomials. Okay, so that's it for our sort of big picture view of polynomials. So that's all for now.